Good morning, everyone. My name is TT, and today I'll be talking to you about why liquid water is the most important part of the habitability constraints and the comparison of Earth to ocean planet scenario. I'll be using the information from Chapter 4, the past, present, and future of habitable Earth. When scientists search for potentially habitable planets, they need a way to narrow down the thousands and planets discovered over in space, obviously, right? And one of the strongest filters that they have is the presence of liquid water, right? Liquid water is very important because all known life on Earth needs it, right? Water serves a medium chemical reaction that supports life. It transports nutrients, waste products, and biological processes to occur. Without liquid water, life as we know it would not be possible, right? Without water, we can't stay alive. One of the second reasons as well why liquid water is very important is the screening tool. It indicates the environmental conditions. If water can remain liquid on the planet's Earth's surface and temperatures can generally not get too hot and not too cold, that means that the planet may have conditions that support the long-term habitability of this water. Obviously, in Chapter 4, it explains that the scientists use the presence of liquid water as one of the first requirements when evaluating whether a planet can support life or not. Right now, I'd like to discuss the ocean planets. According to Chapter 4, an ocean planet is a world covered mostly by water. Unlike Earth, which has both water and continents, and an ocean planet may have little or no exposed land. These planets could contain much more water than Earth and may appear more attractive when searching for habitable environments because water is very abundant. However, having more water does not automatically make a planet more habitable. The first comparison between Earth and the ocean planet involves water and surface coverage. Earth has about 71% of its surface covered by water, while the rest consists of land. Sorry, this balance allows interactions between oceans, atmosphere, and continents. An ocean planet, however, is covered by completely water, right? Leaving little opportunity for land-based processes to occur. The second comparison involves the carbon and weathering. On Earth, we have exposed and land plays a critical in regulating the climate that we have. Rocks on land undergo weather, which removes the carbon dioxide from the atmosphere over a long period of time. This process helps stabilize the Earth's climate and is part of a very important feedback system. Over in Chapter 4, we discussed that how the climate regulation mechanics work and how it can be very different on an ocean planet. If there's little or no exposed land, weather may become very difficult because as a result of the planet not having a lot more land, it's going to be a harder time controlling and controlling and reducing the carbon dioxide levels. This does not necessarily mean that the planet cannot support life. However, it creates an uncertainty whether or not the climate will remain stable over billions of years. We'll have scientists still study whether or not the mechanism might compensate for the lack of land weathering and can it help regulate these climates on these worlds. Chapter 4 emphasizes the habitability is not determined by a single factor. However, habitability depends on how different Earth system processes interact over time. While ocean planets have abundant water, their long-term climate regulation may differ from the Earth's by a lot. Based on this comparison, my screening takeaways are that water should remain on one of the most important criteria when evaluating exoplanets. But scientists should obviously be very careful how they plan on how they're going to regulate the climates. Simply finding large amounts of water is not enough. Researchers have to look